Thank you very much, madam. It was a wonderful introduction that you have given. And it's a privilege to me to be part of this international conference. And as per the, can you see my screen, madam? Is it visible?
Yes, sir. The screen is most visible and you're also audible. You can start with the presentation.
So as per the Gartner's recent report, like what will be the top 10 promising technologies that can disrupt the world, one of the technology that will disrupt the world for at least 10 to 15 years is artificial intelligence and deep learning and neural network. And the presentation will be based on how can we create research champions among the people who are aspiring to construct AI systems and deep learning systems. And this is how the presentation, just a minute. This is how I organize the presentations. I will start with what are the basic DL and AI mechanisms that are there in the existing systems. And I will talk about like various deep learning applications that are already coming. Now, for the last few years, we are trying to apply deep learning in all the domains. And what will be the difference between a traditional system and AI system, and what exactly is machine learning, why we need to go for a deep learning, and possibly if you have time, we will also see a case study also. So we have many definitions on artificial intelligence, like earlier speaker also said, but can we design a system which will think exactly as a human being is what the first mechanism that most of the people has thought, and it's very difficult to replicate human mind. And the second type of systems, most of them like Sophia and most of the other systems that are prominent now, will be systems which will act like humans. Can we develop systems which acts like human beings reasonably well when it is trained and tested? These type of expert systems will be visible for many times. Like in our daily practices also, we'll see this type of systems which fall into this category. Can these systems, can we design systems which think exactly like human beings logically? It's very difficult, but acting rationally is possible. Like if I take a Sophia or Mycin, both of them will come into this category. Most of the expert systems that we have designed or we are going to design now will fall in like, can we design systems which think logically and to some extent can act humanly? So I have a set of examples that I have kept in the slides. Like I have kept a AI system or an expert system that was designed in 1990s, and I have kept a system which was designed very latest in 2020, is called as a Tesla. And Deep Blue is a chess playing game where it has defeated Garry Kasparov in 1992, who is the world champion at the time. Like this, the interesting part is when you talk about a game called a chess game, it is just a 8x8 matrix where two people will be playing. And what type of system we need to design based on the number of predictions, like what, see, I have moved some piece from one place to other place. What can we predict? What is the next step of the opponent? Like earlier, we used to have a game called as tic-tac-toe game, where I play next year, somebody plays over here, most of the people will play here, and I will disable him to see it like this. So my interest is like whenever this type of games are played, we have a 3x3 matrix in tic-tac-toe game, we have 8x8 matrix in this chess game. What type of strategy is needed to predict the move of the opponent is very important. And that is how the artificial intelligence has evolved. And many systems like Rebel, T20, all these are systems which are implemented to simulate these chess games. Very recently, we can see a Tesla is a car producing company where it has produced semi-automated cars, where how can a car can drive without can go without a driver, like driverless cars. Like whenever a car is moving, it has to think about the left neighbor, it has to think about the right neighbor, it has to think about the top and at the back. So when we employ these deep learning mechanisms, how can it preserve? Like there is a horn that was from other car. How can it process this horn like voice at real time? How can it process the video at real time is what the challenge is. Tesla, most of the technology that was used in Tesla is 60% deep learning, where it can process the live videos online, a live voice online, and it will also go for this cruise control and so on and so forth. So there are a lot of changes in the way in which the applications are started in 1992 on this. Like we could see here, I have kept a humanoid robot called as Sophia, where this Sophia is trying to take classes for 8th class students. And how can this a humanoid robot can interact with people and can understand their language? Now, if you see the latest version of Sophia, it can also understand the sarcastic laugh from the people also. So how can a system like a robot called as Sophia can visualize the videos online, and how can it understand the voice of the people, and how can it understand sarcastic nature of the laugh also? So this is what all about deep learning algorithms, where it can process the videos online dynamically, and it can understand the process the videos as well as the voice, and it can, based on the voice it can understand, it can reply also. Very old system I kept here, like the last slide also I kept a old system and a new system. And Mycin is an expert system with almost 296 variants. Now we have 297th variant has come for this Mycin. Initially, Mycin used to assist us, like we have given some set of symptoms. What does your Mycin will do is it will give you a set of diseases that are attributed to these symptoms. But now what happened is by the days it produces, what does this Mycin is doing is it is having the profile of all the people, and what it is doing is it is storing the data of people, and it is also predicting what type of diseases that he can get in future also. This is what now Mycin is doing. It is also assisting doctors to see that what type of diseases he may get in future. This is how this Mycin is doing now. And interestingly, if somebody is having 6 fingers in the hand, what is the reason for having the 6 fingers in the hand? If somebody wish to disable the right hand of the body, what type of cells will do? If some people or some person is suffering with a chronic disease, what is the reason for having that? All this analysis can be done if you have the profiling in this Mycin now. Earlier, Mycin used to interact with people with respect to the text. Now Mycin is interacting with people with respect to voice. Now that is the reason if somebody wish to develop an AI system, it is mandatory that it process voice also. Earlier, the input for AI systems is mostly like text, but now what happened is it is mandatory that every AI system has to process voice, and now most of the AI systems are processing video also. Most of the people know that it is a Hawkeye. Like a Hawkeye is an AI system which will predict the deviation once the ball pitches there. Like how can a system in real time can process a video, and it can tell what type of deviation it will take once the ball was pitched, and how much height it can travel once it was pitched, is what your Hawkeye will do. And the basic algorithms that are background of behind this Hawkeye is also this deep learning. And wherever you go for Twitter, or you go for Facebook, wherever the face recognition happens, most of the applications will be pertaining to this deep learning and neural networks. And we can take many like IBM Watson was there. IBM Watson is a question and answer mechanism. Earlier used to interact with people in the terms of health informatics, like what will be the disease that is attributed to the symptoms, and what type of diseases you can get in future. This type of analysis was done by using IBM Watson. IBM Watson also earlier used to interact with people in the terms of text. Now it is interacting with people in the terms of voice as well as video also. Now IBM Watson is into various domains, not only health domains, it is also into informatics domain, it is also in the insurance domain, many other domains it was there. So the basic background, like how can we process video, how can we process this audio, all these are the attributes of your data learning mechanisms. And we could see here we have a drone here. Like most of the people now, drones are used even to monitor the diseases of the plants, to sow the fertilizers, to just find out the fertility, and so on and so forth. Like even a drone can be controlled by using deep learning and IoT algorithms. And this is a safe mission project where most of the applications are integrated in our house, are integrated with your AI as well as ML algorithms, integrated with IoT. and I kept Alexa and Google. All these are voice applications which are based, can be recognized, and it can be personalized voice assistant apps. Like they can recognize the voice, and based on that, we can go for Apple if it is Alexa. And you have many other systems which process voice, and it will tell you, it will give the customized output. Like if I wished, like if my phone was missing, I can use Google Home. And if I wish to have the songs of some Tamil songs, better it goes for Alexa, and so on and so forth. All this this navigation applications based, see, I wish to travel from Delhi to Mumbai, what is the best path, and what is the, based on the traffic and based on the conditions of the road, how can a system can suggest that path, and so on and so forth. All these are applications of AI systems. And most of you are aware that one of the most important AI system is a weather prediction, where for all the AI and ML algorithms, we need data to process. Like if you have a weather prediction system that you are discussing, we have real-time data. I have the weather data for the last 1 year, I can predict something, but you have a real-time data, like what is the distance between the earth to the nearest cloud, what is the precipitation, and what is the humidity that you are having at this time. All these are the dynamic parameters that will add value. So whenever you add that type of dynamic parameters, the prediction will be more accurate. The same thing, we have almost 170 different type of expert system that predicts the variations of stock market. Like the stock market also, if I wish to talk about stock market variations of TCS for the last 30 months, if I have the data of 1 year, I can talk about the variations in stock market. But stock market is dynamic, and it changes with respect to time. Like some political decision was taken, obviously the stock market value will change based on the news, like whether it is a fake news or a positive news. All the stock market values will change with respect to time. So how can you design an AI system which is having a combination of dynamic parameters as well as static parameters, is what we call it as a stock market prediction. We have almost 170 systems are there. We spoke about IBM Watson. So we have now, people are talking about crowd counting systems, where automatic analysis of video will be done, and it will tell you how many people are there in that crowd in that particular video at that moment. Like now in IIT Madras, people are working on this crowd counting systems. Like in this crowd counting systems, it will also tell you what are the people who are having abnormal actions that may also damage some infrastructure. So crowd counting systems are systems which try to monitor the videos, and at that instant how many people are in that video, and what are the people who are having abnormal actions in the terms of actions which can people who can damage the infrastructure and so on and so forth. So many applications of COVID in the terms of how we use a mask, all this like whether the employees in the particular enterprise are practicing social distancing norms or not, all this, many applications are there in the terms of deep learning. Like so in most of the time, like in Amazon and Flipkart, most of you can see, like in what type of the AI algorithms, what they do is they will try to find the profile of each customer, the way in which he procure, or the way in which he is buying the goods, and they will suggest what type of goods that he is to procure in future. All this will be AI systems. Like very recently in 2020, January 8th, the government of India has launched an e-challan mechanism, where every CCTV that was installed in an NH5s or national highways are integrated with this, what is that called as the speed boxer. Like it will find out what type of vehicles are crossing the prescribed speed limit, and it will what the system will do is it will automatically generate a challan for the cars and vehicles which are crossing the prescribed speed. So this all this each challan mechanism is the way in which you process the videos, And like what will happen in each alarm mechanism is once a system finds that this car is crossed a particular speed limit, what it will do is it will convert that video into set of images. From that images you will get set of card number. From that card number the corresponding email of the owner will be chosen, and they will send an email to that. So all which now we have many examples of the chat box like Alexa or Elisa is a chat box where it will tell you, like it will interact with the people and it will tell you what is the nature of mindset at that moment. It will interact with the person and it will ask how are you and many other questions it will ask, and based on his the way in which he answers, it will tell you like what will be the mindset of the person at that moment. Like most of the time when we try to design, we have a lab called as robotics where 60% of mechanical faculty will be part of that lab and 40% of computer science people will be there, where we try to design robots. When they try to design the robots, almost the movements which the robot, if I say like a robot hand, what is the movement towards left hand side, what is the movement towards right hand side, top and bottom, all this programming part we'll do, and the analysis part as well as the implementation part will be done by the mechanical department. Most of the people now they're talking about creating a robots, like we have seen an example called Sophia, Metaphor. All these are examples of robotics applications. So we have seen many applications of health informatics and navigation also. All this discussion that I have done for the last 10 to 15 minutes is to ensure that people are who are working into this, coming into the AI and machine learning, they need to understand that when they wish to develop an AI system or a deep learning system, it is must that many systems will force us to go for processing the image, processing the video, processing the voice. So now earlier systems like earlier expert systems like Mycin or even IBM, initially when they are working or processing the systems in the terms of voice, now they are doing it also video. So this is a simple slide which will tell you about a traditional system and a neural network system. A traditional system, what it will do is it will take the input and give the corresponding output. But a neural network system, what it will do is it will take a data set, and what it will do is it will know about what type of input has to be given. It also know about what type of output it will get. You will try to deploy a model which will fit for this input and output. So in machine learning, what is that we do is we try to choose a model which will fit for this particular input and particular output, where we can train and test. So many times output is not a major output in the major consideration in the terms of machine learning. So this is a slide where we are talking about machine learning, deep learning, and artificial intelligence. So when I ask you, like I have 20 images, where this 20 images has to bifurcated in the terms of human beings and non-human beings. So it's very easy for us to bifurcate based on the features of this. But if somebody asks me, like I have given 20,000 images, I have asked, like in these human beings, how many are man and how many are animals? In this non-human beings, how many types of cars are there? How many types of vehicles are there? So on and so forth. I asked. And so when the input is more and the features to recognize is also more, than many times what is that we have to do is you have to go for deep learning. When the inputs are less and the number of features identified to use that is less, also you can go for machine learning. And artificial intelligence will have more theoretical part. Like if somebody asks me what is the theoretical definition of artificial, if you wish to implement this artificial intelligence, you have to go for either machine learning or deep learning and neural networks. It consists of concepts like a conceptual dependency. How do you visualize knowledge? How can you store knowledge? Like in conceptual dependency, we will try to represent the knowledge irrespective of the language. That type of concepts you will have in artificial intelligence. And machine learning, most of the people will know, like we try to find out how this model will fit into what type of input and output. So we have various mechanisms in machine learning called as supervisor learning, where we know the class label. We have various techniques in this supervisor learning. And in unsupervised learning, we don't know about the class label, so obviously we'll go with respect to the the futures of the particular candidate, and we'll just try to populate. In reinforced learning, we try to take the feedback. That's what we do when we are designing robots. We try to take the real-time feedback. Based on that, we'll proceed. And we have discussed a lot of drawbacks are there in machine learning. The reason is whenever the futures are more, the data set is more, obviously machine learning algorithms will not give a good result. This is how this is what the slide will give you the correct description, where when the amount of data is more, the machine learning algorithms, the performance is a plateau. It is somewhat static. But in deep learning algorithms, what will happen is when the amount of data is more, also you'll get more accuracy. That is the reason most of the people, when the number of features are more, and apart from that, if the amount of data is more, also they will go for deep learning. And we have many mechanisms in deep learning like RNN, CNN. Like I wish to process a sequential data, I will go for RNN. If I have sequential data where I need to compare things, I will go for the extension of RNN called LSTM. I wish to process a video as well as images, set of images, I will go for CNN. Like now people are talking about Terra neural network, which is a combination of energy efficient DL models. So many other DL models are there, we can discuss whenever it is possible. So these are the references that I have used. And just I have not cited the images. That is the reason I kept this disclaimer. And thank you very much for all the people who have given